Good morning. So we're continuing with review of chapter 11 today. Please make sure you solve this homework, chapter 11 review, before exam. Again, final exam will cover first three exams, first three exam reviews, and chapter 11 review as well. Okay. So there are many. It's just 11 questions here. Today we're going to talk about these questions today. So do you have a preference which question you want to start with? So we may not finish all of them, so I start with your choice. Which one? So here are, in case you didn't check it, here are questions. You need to solve this question by square root property, kind of easy. Here you just need to guess what n should be so you can turn this into a complete square. We call such trinomials perfect trinomial. So is this a perfect trinomial, and what is n supposed to be to make it perfect? Same deal with an uglier number in the middle. Here you're gonna change this into a square by completing into square process and solve by square rooting. Again, don't use quadratic formula here unless it specifies. It says complete square, so complete square, don't use quadratic. I know you can solve by quadratic formula and nobody is gonna police it, but you need to learn how to complete the square, so don't avoid it. Here you're allowed to use the quadratic formula, but there is no quadratic equation yet. You need to first multiply out things and get a quadratic equation, something with a square. Same deal this time. This is really not quadratic. You need to make a u substitution here, make substitution and turn this into quadratic first. And this is not quadratic either because of the square root, and there is no square. So you're gonna make a u substitution. Again, it says u substitution, call something u and get squares. And then we start finding vertex and sketching and labeling important facts about the graph, like axis of symmetry, maximum, minimum, etc. So this is about the last couple sections. Find vertex, maximum, minimum. The equation is already in vertex form, here and there both. You're gonna find vertex, but this is not in vertex form, so you need to first change it into vertex form. Here as well, you need to change into vertex form and answer all these parts. This was the last question we finished yesterday. Maybe you can do this on your own, but any preference on what question you want to start with? Anyone? Then I start with number 1. Okay. Let me know in case you want to start another question. Okay. So square root property means taking square root of both sides. That's it. However, to be able to do this, your question must be ready. What do I mean by ready? The left side, wherever the square is, that square term must be all by itself. Nobody else must be around it. So here, so first thing and most importantly, you need to spot where the square stuff is. This is the square stuff. This is the stuff with a square. And I need it to be alone so that I can take square root. Is it alone though? Is it all by itself? No, I have a -3. So I need to get -3 out of left side. What do I do? How do I get rid of -3? Well, add 3. Yes, we add 3 to both sides. Okay, now this question is ready. All you need to do is take square root of both sides, and here is the most common mistake. You say these two cancel each other as 5h plus 1. You only set it into positive square root. You don't do anything else. And then we solve for this, subtracting 1 from both sides. We get 5h as root 3 minus 1. Or I actually like numbers before the square root. I want to put the minus 1 before 3. Do you mind? So I'm going to put this thing. Yeah, it's not working that way. Okay. I'm going to put root 3 here and minus 1 there. So this is positive root 3. So again, where did minus 1 come from? Because I'm subtracting minus 1 from both sides. Minus 1, minus 1. I'm putting minus 1 here rather than the end. And then the result is almost there. We have these two won't add, and I cannot save 3 from prison. It's still in jail because there is no factors coming out. And finally, to get h by itself, I divide both sides by h and all done. And you will get surprised that this answer will say incorrect. Why? What did I miss? Yeah. When I take square root of both sides, the moment you introduce square root, you need to bring plus and minus option to the number side, not the variable side. The tradition is to put it on the number side. This has to be plus minus. There are two solutions here. One with a plus, one with a minus. You can leave them combined here. This is acceptable. Or if you want to separate them, this is how you separate. Once with a plus, once with a minus. Okay? You either type in these two separately with a comma, separated with a comma, or I hope I can still fix this. I will simply flip this plus sign to plus minus, right, with this option. Okay? And we're all set. Again, if you don't put that plus and minus, only choose plus, it says incorrect and you lose all credit. Any questions on number 1? What's the lesson we got? We need to get the square alone, put square root, don't forget plus minus, and type it in. That's it. Second question. What number is required here so I can turn this C and plus a number squared? So I can turn this into C plus a number squared. How do I know it's plus? Because the sign is here plus. What number should we choose for n? Anyone? How do we compute that number? So when you square this question mark, it's gonna be that number. When you FOIL this, you get positive 3c. I don't know this number, I don't know that number. We will find both. We will find n and then factor the trinomial, and we will find this green number. So you will first find n and then find out the green number. But when you are finding n, you will actually find out green number as well. Anyone? Come on, we can finish early if you contribute. What is that number n? How do you find it? Right, right. All you need to do is take half of this number. What is half of 3? 3 halves. You can't divide 3 by 2. So it's 3 halves. Or if you like, you can change this into 1.5, but that's not necessary. 3 halves is fine. And then we square it. And this becomes, what is square of 3? 9. What is square of 2? 4. 9/4. That's it. Okay, then how do you turn this into square now? That's the whole idea. That's why we are getting that. And I know the first part is C, the second sign is plus because it's positive 3C. But how do I find this green number? It's already found. Positive 3 halves here, right? That's it. This half the amount is used up here. Okay, number 3 is very similar. It's just uglier numbers. But do we care how ugly this number? No. You take half of this number. So how do you guys take this and take half of it? It's half. There are several ways you can do this because they are on the both numerator, because 2 is actually 2 over 1. As long as you cross out something from both denominators, you're fine. So it turns into minus 1 over 5. 1 over 1 is 1. Minus 1 over 5 divided by 1 is minus 1 over 5. That's one option. Or if you don't like canceling out this way, you can do this. You can bring it upstairs by flipping. Flip and multiply. When I flip and multiply that 2 over 5, look, when this travels here to next to 2 over 5, it becomes 1 over 2. And they still cancel, look. And get 1 times 1 is negative 1. Negative 1 times 1 is negative 1. 5 times 1 is 5. So this thing is negative 1/5. Negative 1 over 5. Half of 2/5 is 1/5. You can even do it by reasoning. But what is really n? N is 1/25. You square 1 over 5. Oh, it's negative. Shall we take negative? No, when you square negative number, it turns positive. So we don't care about the sign at this moment. N is always positive. So it's 1 square over 5 squared, which is 1 over 25. That's it. Okay, what is the completed square? It is a plus this number, right? 1/5. Am I right? Are we right here? If that's 1 over 5, so I'm squaring this as 1 over 5 square. Am I right? It's minus. 2 reasons. Because either you go with this sign here, it's a minus sign, this has to be minus, or you found minus 1/5 here. Why do I put positive, right? It should be minus 1/5. All right. Next question. Again, if you guys need more explanation, this is what you need to do. Go check the section number 11.1 and we can watch the entire section from YouTube again, alright? In case I still need more details, you can go, because we've done pretty much similar question, maybe the exact same question earlier. Alright? By the way, I hope to upload all missing videos today, okay, by the end of today, so everything should be on the page. Alright, next question. We are going to now look. In the last 2 questions, you proved you have some skills here, completing into square skills. You're gonna now really put that skill into work in this question. To be able to solve this without quadratic formula, you need to complete this into square, and this is how you do it. First, get rid of these numbers, switch it to the other side, and get t's alone. Look, I'm subtracting 12 from both sides. Get that number out of our way so that we can have all variables on the left side. Why did I put a parenthesis? It's not necessary, but sometimes there is a number in front of t, like 2t squared. You need to factor out outside parentheses. That's why I put parentheses, but here it's not necessary. Look, sometimes there may be a number in front of t, and you need to factor it like this. 2 comes out from both t squared and 8t, and this becomes 4t. Then you need a parenthesis definitely for such situation. But right now we don't have to. We don't need a parenthesis, but I will keep it anyways. Now next, just like you did in the earlier two questions, I want you to come up with a number here so that we can turn this into square. This 3 term will turn into square with t plus a number. It's a plus because I see a plus here. What is that number going to be? Come on. 4 squared. Yep. The number missing here is half 4, but when I square it, it's gonna turn into 16. Are we done? No. When you put 16 here, you gotta do it immediately without any time waiting. You don't have to wait. If you wait, you miss it. Before going to even this step, you need to do this here, right here. I'm adding 16 here. I must add 16 to that side as well. Or if you don't want to add to this side, then you must subtract from this side so that they can cancel. But I find adding, instead of subtracting here, adding to this side more convenient. Okay? So if you're adding something to the left, you must add to the right. Or you must subtract from the same side. That's another option. But adding better. So this is 4. Look, this question now turned into number 1. It's not different than this question. Something squared equals a number. Look. Something squared equals a number. All we gotta do is taking square roots. And when I'm doing it, don't forget to put plus and minus. So t plus 4 equals plus minus square root 4 is, can we take 4 out? It's 2 squared, 2, right? And subtract 4. And we get plus minus 2 minus 4. Well, you can compute this in 2 steps. First step, you take the positive sign and compute it. Second, take the negative sign and compute it. And you get 2 solutions, minus 2 and minus 6. Then I take the positive option first, negative option next, and get minus 2 and minus 6. Everything clear here? Alright, this time you're allowed, you have a pass to use quadratic formula, and let's recall that. This is the quadratic formula we're talking about. Well, for this quadratic formula, I need something like this. I need a square equation and x and c. I need square x and c, a, b, c's. I don't have it here. So first step we're gonna do is prep this question by multiplying out. Clear all parentheses and get squares and k's. Do you see that? Well, this is still not ready. I need to see a single square term. I have 2 of them on separate spots. So we need to combine like terms. 1k squared negative 7k squared makes negative 6 in total. I have some spot with k, so I can combine them as well. Positive 2 minus 21 makes minus 19k. And how do I do it? What do I do with this number? I'm gonna bring this number to the left by subtracting left side from left side negative 3. Add negative 3 to both sides, in other words. Now, perfect match. Ax squared bx plus c. Alright, this is okay. You can now apply quadratic formula. However, I do not like dealing with negative numbers. Look, everywhere A, B, C's, you see the negative signs? I don't like them. How can I get rid of negative signs? We multiply both sides with negatives and flip negative times negative 6, negative times negative 19, negative times negative 3, all turns everything into positive. This turns from positive 0 to negative 0. This is ridiculous. 0 doesn't have sign, so 0 won't change sign because it doesn't have one. So best way we can work with this question is it positives, and I did it. I changed everything into positive. Any questions? Now, shall we apply this formula? Instead of x, you have k's here, but if you're more comfortable with x's, you can make these x's if you wish. But I will still use k's. So k will be two values. One is negative b plus, the other one is negative b minus. But let's first put these numbers in place. B is 19 plus minus 19 squared minus 4ac over 2a. Okay, minus 4, 6, 3 makes 72, minus 72, 19 makes 361, 19 squared, is that so? 361. This is 361. This is minus 72, is triple quantity. When I subtract, it is 289. First take a calculator and punch in these numbers, see if you can compute square root 289. I believe you can. Square root of 289 is, it's 17 times 17, so it's 17 squared, right? So it's 17 only. There will be two answers here. One is positive option. The other one is negative option. This is 16 over 12. I can reduce both by 4. 4/3 is the first one. Second one, I can reduce these by 6, 3, and 2. Cancel both by 6. It's negative 3 halves. 4/3, negative 3 halves. I believe the answer is if you haven't had any mistakes. Any mistakes?
How did you get 1? Negative 1.
Yeah, I was checking you guys on this one. Yeah, it's negative 19. There is a mistake. Thank you. That's negative 19. Negative 19. Negative 19. Negative 19. Our final results will be different, of course. That's minus 2 over 12. That's minus 1/6. Cancelled by 2. And this is minus 36 over 12, and that's minus 3. Minus 1/6, minus 3. Any more mistakes? Might be, because this is a long process. If you rush like I did, you will make mistakes. You see, nobody is safe. If you don't double check your work, mistakes are everywhere. Good. There's one way to check this before entering Connect Math. You can enter these values into equation and see if it makes it correct. Putting -1 in and checking it is really difficult, but you can at least do for -3. You can enter -3 here and see if you get this answer justified, if you wish. Okay, ready for the next one, but before there's any question. So this is a straightforward application of quadratic formula once you get the standard form, of course. Here though, we need to turn this into real quadratic one, because with this square and double square, it's not quadratic, it's 4th degree when you multiply this out. So we are gonna first make a basic substitution. I will call that parentheses m squared m for m u. I will call this entire inside, replace it by u. Oh, if I call this u, then I must call this one u as well. So the equation turns into u squared plus 11u minus 12. Wait, how did I get minus 12? How did I do that? Where did minus 12 come from? Yep, I brought 12 to the left by subtracting 12 from both sides. That's how. Okay? Why do I need to do that? Because to apply quadratic formula, I must have 0 on the right side. I can't work with 12. Alright, let's do the formula. U will be minus b, minus 11, plus minus. Look, I don't even need to write the formula. I memorized it. Maybe you did at this moment as well. B squared minus 4ac. You should be able to do this fast at this moment. If you're not, that means you need to practice more. First, multiply these three numbers all the time. Minus 4, 1, and minus 12 makes positive 48. 11 squared makes 121. Always work out the square root first. 121 plus 48 means 169. Okay? Good question. Is it minus 48 or not? Look, I multiplied minus 4, 1, and minus 12. Minus 4, 1, minus 12. When I multiply the first two, it's minus 4. When I multiply the later two, it makes positive 48, right? Since I involved this minus sign with 4, there is no more subtraction left here. Everything turned into positive, okay? It turned into positive. So again, if you multiply these three numbers with this minus sign, you no longer need to subtract. Whatever the result you get, you put it with that sign. If you get a minus here, it's gonna become minus, of course, but I got positive. So 121.48 makes 169. Is that right? Okay, that's great news, because 169 is computable as a whole number. 169 is 13 squared. Square pays off the bill and 13 comes out, right? Perfect. Now it's time to separate this into two parts. Why 2 parts? Because you have plus minus. One with a plus, one with a minus. Alright, you will get 2 over 2 here, which is 1. You will get minus 12 here. How? Minus 11 minus 13 makes minus 24. Half of 24 is 12. Negative 12. So we're done. 1 and minus 12. Mission accomplished. I remember doing this back then. We found 2 solutions, right? Did we really find 2 solutions? Yeah, but how come it's not accepting? What is wrong? Says it's not the right solution. You don't have 2 solutions here. Why? Yeah. U is this guy. They're expecting an answer for M. You're providing them an answer for U. They don't even know what U is. You made up that variable. So you need to put back what U was. U is M squared minus 4M. Make all U's into that. Alright, here comes more trouble. I need to solve for this again by quadratic formula, because this is quadratic again, 3-term quadratic form. I need to do quadratic formula. Minus b plus minus b squared minus 4ac. How did I get 16? It's b squared. Because I'm getting faster and faster when you do more and more, okay? But this time again, minus 4, 1 and minus 1. This side turns into positive 4. 16 plus 4 is 20. But I know 20 has a factor as 2 squared and 5. I'm breaking 20 into 2 squared and 5 because 20 is 4 and 5. 4 breaks as 2 squared, and I can save 2 out of this jail. And even better, we can distribute this 2 to both and divide and get a simpler answer as 2 plus minus root 5. Because 2 over 2 is 1 root 5. Clear? So you found 2 solutions already. There are 2 solutions here. I bet we are gonna get another 2 from this side. Let's try. I'm first bringing 12 to the other side, and there is a shortcut at this moment. Do you guys like applying quadratic formula? Do you like it? Do you enjoy it? If you do it, do it. Do it another round. But I enjoyed this one better, if possible. It wasn't possible here. I didn't even try. How do I know? Because when I split 1 into 2 numbers, they will never add into minus 4. I knew it. So I didn't even try. But here, when you split 12 into 2 numbers and FOIL this, it can make minus 4. What 2 numbers make that? What 2? Yeah, negative 6 and positive 2. There you go. You found 2 solutions. Set them into 0 now. You're setting each into 0. A lot faster than quadratic formula and less risky. This is risky because you do a lot of operations here. I've done it right because I'm experienced, but you guys, when you're doing it, you probably do multiple mistakes here. So it's risky to do quadratic. This has less operations, a lot safer in my opinion, but still most people mess up splitting this up right way. So there is still some risk for you. 6 and minus 2 are another pair of solutions. There is already 2 you found. In total you have 4 solutions on this messy question. Okay? And what are they? Oh, they want all separate. Great. So first one is positive option. 2 plus square root 5. 2 minus square root 5. 6 and minus 2. 6 and minus 2. Check. Oh, hate this. Here's my mistake. You see, I made a mistake. Where? Oh, 6 is positive and m is minus 2. Where did we mess up? One and minus 12. We may have a mistake here. I don't know. Minus 13, 12, 1. Oh, by the way, you could have factored right here. You didn't need it a quadratic formula application here. You could do u minus 12, u plus 1 factoring and get the same answers. So up to here we're right. U is 1 and minus 12. Is it the same question we're solving though? Sometimes it flips the question. No, we're good. It's the same question.
Let's slow down for a second. 12 is positive.
Oh, this one?
Yeah, so it can't be negative 6, right?
So negative, but there should be
Oh, hold on. Why is this positive?
like m squared minus 4 is plus 12, not minus 12 factor as it is negative 12.
Yeah.
Oh yeah. Who gave me these numbers? Alright. Okay, so these numbers, I was warning you, you can still mess up factoring this, and we did it. So it should be positive 6 minus 2, right? No, it can't. It's not true. So even positive 6 minus 2 is not gonna work. Yeah, this can't be factored. This can't be factored because 6 and 2 they need to be same sign. Minus 6 minus 2 or positive 6 positive 2 to make 12. They will never make 4. Wow, it looks like factoring, but it won't. Can I try 4 and 3? 12 is 4 and 3, but 4 and 3 will not make minus 4 again. 12 and won't make. Wow, we are stuck with quadratic formula. Minus b plus minus square root b squared minus 4ac. Oh, it has complex roots or solutions. Look, b squared minus 4ac. 4ac makes, this time negative positive multiplication makes minus 48. 16 take away 48 is what you have under square root. Terrible. Why? Because if a negative happens under a square root, like negative 32, you need to first sanitize this chair because it has a virus in it. This virus. And how do I sanitize it? Take out an I, yes. Or take I to the end. I like it and in the end better. So it's root 32i, but I still believe some of that 32 can come out when you break 32. How do you break 32? Isn't it 16 and 2. And 16 can come out as 4, right? Yeah. 16 is 4 squared. 4 comes out. So the final answer is 4 plus minus 4 root 2 I over 2. And even better, when you pass this 2 to both denominators, they cancel. Alright. 2 plus minus 2 root 2 I. That's our new pair of solutions. It's no longer whole numbers. It's both fraction, two-piece complex numbers. 2 minus 2 square root 2 I. 2 plus 2 square root 2 I. Am I right? Yep. Oh. Where's our other mistake? For the records, this question is this is correct, but ConnectMath is not accepting it because they have a mistake in their solution. 4 and 2 cancels, and this can't be the right answer for them. The other side matches. The 2 plus minus root 5 is the same as ours. I don't know why they did this, but computer has a wrong answer. Okay. So we are skipping number 6. I will probably delete it from our homework as well. Okay. Because it's registered. Wrong answer is registered. We made an earlier mistake, but we fixed it. The right answer is positive 2 root 2 root 2I. Alright. We are gonna do another U substitution question, but this time it's not as clear as the earlier one. You need to figure out what to be called U here. Here's some help. Whatever you call U to be here, it needs to pop up here as well. So I immediately see this has to be called U. So I know before even I start, oh, U is root Y here, but how? Because this Y here is actually square of root Y. Because when you cancel square root and square, it turns into Y. So I can make this Y into square root Y and then square it. And this second guy already have root Y. And when I call this thing U, and that one automatically becomes U, the equation becomes U squared minus 7U plus 6. How do I get plus 6? I'm just moving this number to the left. Okay? So the right conversion, U substitution here is U equals positive root Y. Technically, usually, look, even here, that U substitution is always hiding in the second term. In here, it's hiding right here. Okay? You just need to make the first term into a square though. Now let's solve this by quadratic formula again. No. First, I try factoring. How does this factor? Does it factor?
-1, -6.
Yep. This time you're right. So you set each into 0 and get two solutions. Okay. Once you set them into what they used to be, root y, we will be all done. U is root y, U is root y, but we need to get to y itself, not root y. How can I clear a square root around our variable? We square it. Square both sides and all done. 1 square is 1. This cancels away and y is exposed, free, set free. 6 square is 36. Two solutions, 1 and 36 is the result. Alright. Now we're almost done with the old stuff. Maybe you had a hard time recalling that. It was good, so we reviewed them, but 11.4 and 11.5 are recent subjects. For example, this one is very easy. This is already in vertex form. Can you read me the vertex here just quickly? What is the vertex here? Yep. Axis of symmetry is -5, this number. Domain of all quadratic functions is always the same. This part is the same in all questions, which is, yep, all real line. Range, the other way. It's -3. You start with -3 and go up. Oh, hold on, we don't know. Yeah, you're right. So for range, if possible, sketch this. -5, -3 will be here. You're right, sorry. This is the vertex, and because of the negative sign, this thing going down. Since it's going down, range is this red zone. It's -3 and -infinity, so we start with reading from the bottom. So it's -infinity to -3. Okay? Now what is different in this question? Nothing. Just they are asking this time maximum value or minimum value. You have a minimum point, not maximum here, because this is going upright. Because of the positive sign, you have a minimum value, and that minimum value is this number, -1/4, negative sign, and the vertex is 3 and -1/4. We've done many of these, so I'm kind of just quickly going over. The last two questions are from yesterday, and I believe you can do them as well. It's been a day. Alright, couple announcements again. Exam is